This is case study 1 for control theory. So, this is the problem that I solved. First, we had to take the problem, which was problem 1. Then, we had to solve it. First, we had to find the system of equations in the time domain. Once we had that, we were able to put it into the frequency domain and get our transfer function, which I will explain later. So, after we got our frequency domain function, we needed to put it into MATLAB. This was just the normal MATLAB, and then I proceeded to plot it. As you can see, I put the transfer function in, and then I plotted it. I also was able to plot it in the same amplitude and time as the next two graphs. As you can see, there's two little divots and one bump, and then it proceeds to flatten out right around 0.32. So here's Simulink. This is the transfer function. One thing I forgot to mention in the previous slide was that the previous slide was the frequency domain. This is also the frequency domain. As you can see, it has two bumps, or two divots, and one little bump. I also plotted it as the same time and height. As you can see, it levels out around 0.34, close to 0.35. It could be 0.33. As you can see, it was pretty straightforward. Alright, this is where I plotted the time domain. This one was much more complicated using Simulink. We had to take two functions which were solved and then figure out how to interlink them. After I figured out how to do that, I was able to get a plot that was similar. As you can see, it has two little divots and two little bumps. It also levels out right around 0.33 or 0.34. Very similar to the previous graphs.